Hi, everyone. Welcome to our next webinar. And let's do a quick check. We hope you can see our screen well and you can hear us clearly and well. If you have any troubles with watching us or hearing us, please let us know in the questions tab. It looks fine, so we don't have any technical problems. And let's get it started. So hi again. My name is Victoria Gadaichuk, and I am doing a product management for Trimble MX solution. And today I'm happy to greet you at our Mobile Mapping Essential series and our webinar using of Trimble MX7 for asset management applications and populating a GIS. Today I'm here with my colleague Peter Houghton, who is the business development manager for Trimble Mobile Mapping Solutions. And Peter will be presenting you the content today, how to use our imaging rover for asset management application and GIS. Just to make it clear on the start, how we handle our questions, I think as usually, you just let us know once you have questions in the question tab or in chat tab. And we have our 10 minutes at the end of the session and trying to answer as much your questions as possible. With that, I will hand over to Pete to present a content to audience.
Hi, everybody. I am Peter. Good morning, good afternoon, good evening, wherever you are in the world, and welcome to this Mobile Mapping Essentials webinar on the MX7 and how you might use it for asset management. So, introduction to the hardware, first of all. So we have several pieces of three hardware products essentially for mobile mapping in Trimble. And you'll see we split them into three categories here: GIS mapping, survey basics, and survey. So we have the MX9 in the survey box, which is kind of high density point cloud, and I guess is our flagship product for surveying applications for mobile mapping. Then in the survey basics in the middle, we have the MX2, which is a less dense point cloud data collection process for surveying. And then in the mapping, we have all three, and we have the MX7 added, which is an imaging only system used for GIS and mapping and kind of asset management. So yeah, so that's another way of looking at our products. And just for clarity and to make sure you're on the right webinar, this webinar will talk about the MX7 mobile imaging system and its use for asset management and populating GIS. So MX7, our idea when we launched this product was to remove the complexity from mobile mapping systems. So up until the point that we launched the MX7, I think a lot of mobile mapping systems were quite complicated, involved lots of computers and computer racks in the backs of cars, and lots of cables, and lots of things that can break quite easily, and reasonably complex to operate as well. So our goal with the MX7 was to try to eliminate all that, if you like, remove the complexity, have something that's very easy to install, simple to operate, and can be moved very easily from one vehicle to another. And also we wanted to reduce the cost and make mobile mapping accessible to more people. So what is the MX7? It is a mobile mapping system that allows you to visualize and share information. Obviously, it's a corridor mapping system by the very nature of mounting a sensor on a vehicle, kind of defines a corridor. Mainly used for asset management, but not totally. Could be also used for inspection. Could be used for network management in terms of running network here, for example, a road network, or it could be network of electrical distribution, for example. So it's a 360-degree imagery. We position things in the images using photogrammetry. We have an integrated GNSS and inertial system inside the unit, and an embedded computer that does all the hard work and records the data. So these are some of the typical applications that we've seen for the MX7. So obviously road networks are quite a popular one because you're often driving on roads. But we've also had MX7s mounted on platforms on a railway for doing railway network management. For inspecting assets along the side of the road, could be road signs, lamp posts, posts of all different kinds, could be to do with utilities, electrical utilities, water utilities, mapping manholes, that kind of thing, and also for documenting things in some specific industries like oil and gas, where maybe they want to kind of do a cross between mapping their infrastructure and also doing, if you like, the first level of inspection as well, just making sure things are in a reasonable condition, which of course you can do very easily just by driving past something with a 360-degree camera. Another area that's becoming very popular these days is 3D city mapping and uses for architecture and city planning. That's a growth area that we're seeing. But probably overall, we have a lot of people just basically want to do their own Google Street View, if that sounds not too strange. I think a lot of people want to do that, have their own accurate Google Street View that they can do whenever they want of their local area and capture their local environment and update it as often as they like. And then we've also seen some uses for surveillance and security kind of applications. Maybe, you know, we've had some uses where maybe there's going to be a big event in a city or something and they want to map out the security impacts on what that event could look like from a security point of view, and it's useful to have very up-to-date imagery of the environment at that point. So MX7, you'll see the image there is capturing the 360-degree image. That's what we get from the MX7. So inside we have 2 terabytes of storage. We have our 360-degree spherical camera with 30 megapixels in total. So that's 6 cameras, each of 5 megapixels. And then we have a Trimble Planix GNSS system in there that's giving us, in the best case scenario, with no kind of GNSS outages, could be down to the 2 to 5 centimeter level. Obviously, it's a GNSS based system, so it does depend upon your GNSS environment. So what's in the box? So the sensor itself has the GNSS antenna on top. Then it has 360-degree camera. We have the IMU inertial system. And then we have our storage and software in a PC. So it's completely self-contained, if you like. So no need for computer racks or any of that kind of stuff. Basically, just about everything you need is in the MX7 sensor head itself. So on the outside of the vehicle, first of all, we have a roof rack. So the roof bar is supplied by Trimble. The MX7 sensor head mounts easily onto that. So to dismount it and then mount it again is literally a 5-minute job. It's just 4 or 5 screws that you tighten with an Allen key. We may have a second antenna. This is called GAMS. This is a secondary antenna for helping to measure heading. It's kind of constantly recalibrating the inertial heading against a very precise GNSS-based heading. We may add a DMI, which is a distance measuring instrument, which basically fits to the wheel of the vehicle and measures distance. Again, this is useful in harsher GNSS environments because it gives us another distance input into the system, but it's also useful for detecting, for example, when the vehicle is stopped, and we can understand that very well from the DMI. Inside the vehicle, so your vehicle will of course have its vehicle battery. We would take a 12-volt supply attachment from that. We would then attach that to our power box that sits inside the vehicle. This also has a Wi-Fi adapter attached to it that gives us wireless network inside the vehicle. And then that is attached to the MX7 sensor head itself. And then we would attach a tablet, or it could be a cell phone, or it could be a computer. Basically, it's any device you want that's capable of attaching to the internet, usually by Wi-Fi, but we can also use a LAN cable. So for example, if you wanted to attach a PC with a LAN cable, you could, a laptop with a LAN cable, you could do that. But most people use an iPad or you know, some kind of smart tablet. So then I mentioned that we have used it on a number of different platforms. So this just illustrates some of those applications. So I guess predominantly on cars, but we've also had it on trains, on boats, on things like quad bikes. And I think that's one of the nice things about the MX7 is that it's very easy to swap from one vehicle to another. You don't need to think about calibrations or any of this kind of stuff. You can easily move it from one vehicle to another. So it's very easy to use. So the software is very simple. We designed it so that it could be used by reasonably non-technical staff. So if you had, for example, a vehicle driver that's 50% intelligent, they could probably operate the system. And yeah, we install it on a bunch of different platforms, as I said. So the TMI software itself, so basically we're just connecting with a web browser. So when you go into your tablet or whatever device you're using in the vehicle, you would launch a web browser. Normally we use Google Chrome, but could be other web browsers. And then we attach to the MX7, and the software itself is running on the MX7, and you get an interface like the interface displayed on the screen there. So, which is very simple. So basically, there's a settings tab that allows you to set up some very basic parameters around the vehicle. You can give your vehicle a name. You can decide what interval you want to capture images at, that kind of thing. Then there's the mission screen itself. So the data capture project we call a mission. And then you see some very simple screens like this. So there's basically two main options, a camera option and a navigation option. Navigation option gives you status of your GNSS system so that you can check that everything's working okay. And then the camera obviously displays the images of the cameras, and you can see that everything's working there. When you're ready to record data, or a run as we call it in our mobile mapping language, you just simply hit the green record button, and that will start to record data. And when you're ready to stop, you hit the red stop button. So very simple. There's also some tools for transferring the missions once they've been recorded. So normally what you would do is you would attach a external hard drive to the MX7, and you can use this function here to copy the data over to your hard drive. Just make sure that all the necessary folders, etc., are copied over, and also gives you an indication that it has been copied, and it won't let you delete a mission that hasn't been transferred, for example. So a little bit more now about what happens in the office. So once the data has been captured, what do we do next? So in Trimble, we have talked about already the section on the left, the collection part. The next step is to process the vehicle trajectory. We do this in a piece of software from Planix called POSPAC, which allows us to take that trajectory against a local base station and process the best trajectory we can down to the centimeter level. Then we would, most people or many people would then be interested in extracting data, managing the projects and extracting data from the images. That we would do in our TMX asset modeler software, which allows us to support GIS data formats and workflows, and allows us to measure and extract things using photogrammetry. And then finally, on the right, you'll see we have the ability to publish the data. So that means giving users the opportunity to share the data across the internet, across an organization, and so maximize the value they get from the data by sharing it across as many departments that can benefit from it as possible. And this is very important, I think, to be able to maximize the data. No point in collecting lots of rich data, using it for a very narrow application when there could be lots of other people interested in using that data for other things. So Trimble MX software, I'm going to show you some short demonstrations on how to extract data using MX software, and then also talk about Publisher a little bit as well. So data extraction. So this is inside our Trimble MX Asset Modeler Pro software. So the first thing you would see once you'd pulled in the processed data is you could look at your trajectory and see some quality parameters relating to the trajectory to make sure that you're happy with the quality of that data. So you'll see this is all colored green, which if you look at the trajectory display there, basically means that it's yeah, centimeter level trajectory. The example I'm going to run you through here is we had quite a lot of interest over the last few years from the fiber to home business, which is basically installing new fiber optic cables for expanding broadband networks. And we've had quite a lot of users using MX7 for this application. So I'm going to use this as an example to show you some of the things that that kind of customer has been using the MX7 for. So first of all, here's our image view in MX software, and one thing that a fiber to home customer might be interested in doing is planning where they're going to put a trench for a new fiber optic cable. So just by visually inspecting the environment here, they're able to decide where they're going to put in this case, a buried cable. So it may not always be a buried cable, but in this case it is. And you see they're selecting the surface type. Surface type's important because they know what kind of equipment they need then to dig that trench. So from this information, they now have it on the map and can plan for that project to basically dig that trench. The next in the same area, it's not really so much to do with fiber optic cables, but I'm just going to show you how we would, for example, add if we wanted to extract the curb line along this road, we would add an inventory item. In this case, I've set up something called curb line, and I select a tool that allows me to build a polyline. So I can simply virtually drive along the road, if you like, and click on the curb line and extract that information. And again, because TMX has a kind of GIS engine behind it, you can, of course, to any of these features, you can add attribute information. So in this case, the type of curb, and then also automatically it's calculating the length of curb that I've extracted there, etc. And you'll see in the top, it's shown displayed on the map in yellow, and then also now I'm displaying it in the image window also in yellow. So another thing I learned about the fiber to home business is they quite often interested in looking at what infrastructure already exists in the environment that they could maybe reuse for their new fiber optic infrastructure. So in this particular case here, one thing that was of interest to them was the location of manholes, because these could potentially be reused. So in the UK, they actually call these chambers, because there's a, I guess there's a chamber underneath the manhole. So in this case, I'm using an area feature that's a rectangle defined by 3 points. And again, I can say what type it is from a drop-down list. I've predefined those. The area is automatically populated, and then I've got a notes field as well for adding any further information. So there we have our extracted manhole, and then you'll see on the map, and it's been labeled with the area or the size of the manhole. And then this is another one here. It's just a different type of manhole, circular one. So in this case, I'm choosing a circle defined by 3 points on the perimeter. So again, you see it's labeled with its area. Attribute information, same as before. And then you'll see also on the map is the location of the manhole with labeled with its size or area. So another thing that is of great interest, and this one I think is quite critical to the fiber to home business, is so if the blue line down the middle of this road here is my cable run, I want to measure what is the offset from that main cable run to the property boundary. And this is really important, because if I'm a new customer that's wants to connect here, then as a customer, I'm going to pay for this part, right? This is my connection. So this is a valuable piece of information to understand what this offset value is. So I've measured it here and labeled it into a feature. It's 9.7 meters. And so obviously from that, you could calculate a price of how much that's going to cost to connect that property to the main cable run. I just wanted to show you this as well, to really just show you TMX software has quite a sophisticated GIS system behind it. So I can do things that you would expect to do in a GIS, like a query. So I'm going to build a query here, and I'm going to query, if you remember, I was extracting cables and I was storing the surface type. And in this case here, I'm going to run a query for all the cable runs where I've identified the surface as soft verge. So soft verge basically means like grass embankment or something. So you'll see it's found, I don't know, 1, 2, 3, 4, 5 trenches that are soft verge. So obviously soft verge is important, because if this was a cable run that's going to be put in grass, then it's probably very cheap to do it, and they need fairly simple equipment to be able to bury that cable. And then that can, once that query's been run, that could be exported, say as a DXF file, and maybe sent to a subcontractor that's actually going to dig these trenches, for example. Okay, another thing that's really useful in TMX is maybe after all the work's been done, maybe you go back, the trenches have been dug, the cables have been put in place. Now you want to do an as-built survey. Maybe a subcontractor did the work of installing the cables, and now you want to inspect it to make sure that the ground surface has been returned to its original condition. So here I'm going along where the trench was, and I'm just putting some points on the trench and just making comments to whether the trench was returned to a good condition or not. And then I can add snapshots, so I can add an image as an attribute to that point. And then I can move along to another one, maybe a bit further along. I can inspect the trench again. I can add another point. I can make a comment to whether it was good or not. And then I can add a snapshot. So that's a saved image of that view that you're seeing there, attached to that attribute that anybody could pull up in a GIS system, for example. In this case, I'm going to inspect a different thing. So quite often, it could be that they want to, rather than bury cables, they might want to suspend cables from existing posts. So I've just extracted a point on a post here. It's given me the height of the post as well. And then I can also look at that post and also make an assessment of, does it actually have space on it for me to install my own components for my fiber optic cable. So I'm going to zoom in and I'm going to make a snapshot of the top of the post and say, yeah, there's space on that, and here's a picture of the top of the post. And then that's stored along as an attribute. So you get the idea of the inspection workflow. And then you can also do verification. So maybe you have a manager and he wants to go through the inspection workflow and just check it off and sign it off if you like. So you can create a list of items to inspect, and then using this utility here, you can quickly click through them and accept them or reject them. So it's quickly just going from one object to another, takes me to the location, I can inspect it and I can accept it or I can reject it. So I think this is a really important part of using imagery as a mapping tool, is not to forget how useful imagery is for kind of doing virtual inspections. So this kind of virtual inspection workflow is really useful. Just to mention that usually in the top window here, the map window is by default, it would be an OpenStreetMap background, but any mapping that's available as a web service can be attached here. So in this case, this customer, this is in the UK, they had access to kind of very large scale ordnance survey mapping, which is this mapping here, and we just connected to it using their account to connect to the Ordnance Survey map service. So once you've extracted your data, it can be exported in GIS or CAD formats, let's say, depending on what's most appropriate for your user. And then we can also publish the data. So there's the TMX publisher, and then there are also third-party publishers like Mapillary. And I'm going to talk a little bit about those now. So as I mentioned earlier on, one important thing with mobile mapping data, to maximize the value from the data, I think it's really important to share the data across an organization and really maximize the value of that data. And one way of doing that is by using a publisher or publishing the data in some way. If we use our Trimble MX software publisher, we can also attach plugins. So for example, there's a plugin for ArcMap that would allow you to extract data directly using the plugin directly into ArcMap. So that's a very nice tool. Probably not something you would want to use for huge amounts of data extraction, but for sharing data and doing small extraction, it's a really useful tool. So a little bit more about some applications now. So this is the TMX publisher. And once your data is published on the internet, you can basically, as I've done here, you see the URL at the bottom. I could cut and paste that in an email to somebody, and they could basically click on that URL and they could open the published data in a web browser, simple web browser, and look at the data like I'm doing here. So this is just reviewing the data in a web browser. I'm able to play through the images, see the image locations on the map, and then I can do some extraction. And in this case, I'm going to use a tool to just measure the distance across the width of the road. So if you look at the right-hand window at the bottom right, just by simply clicking in the image, anybody that has access to this using the publisher can do things like this and use the information to make their own custom measurements, if you like. So I'm going to show you some other examples that we have on our demo publisher. So these are all the publications we've got. So for example, this one is a totally different application. This is a mountain kind of cycle path in Italy. So this is more of a leisure or tourism kind of application where MX7 data has been used to record the route of this cycle path. I thought I'd go through this tunnel just to show you it still works through the tunnel. And then I'm going to show you another example here, which is on a waterway in Amsterdam. So you'll see now the MX7 has been mounted on a boat and is recording the data as the boat moves along the canal. And then finally, one further example from Germany, where MX7 was mounted on a train, and you can see here for how useful it could be for extracting, all the information along this corridor. Maybe you don't even want to extract it right now, but at least to record what is along this railway track. It's a really efficient tool to do that. Okay, I mentioned another product which isn't a Trimble product called Mapillary earlier on. Mapillary is a open source web-based image, kind of your own Google Street View, if you like, software, and the MX7 is supported. So you can export your MX7 images, open an account with Mapillary, and upload them to the website. Now, the downside of it is, unless you have a commercial relationship with Mapillary, then because it's open source, everything's available, all the data is available for anybody to see. But yeah, if you're looking for something low cost, then that's a possibility. If you want to do something that's a bit more private, then you can pay them some money and get a private account, I think. But what's really interesting is, and this isn't the only piece of software that does this, but it has some nice AI features in here. So for example, you can run a routine to auto extract road signs. So let me just play this. So I'm driving through my data set. You'll see it's automatically identifying and extracting road signs. They can be exported as a shapefile or whatever. So you see the road signs being automatically identified. It will identify other signs as well that maybe aren't in its library, so it just won't classify them into a particular kind, but if it can see what they are and they're in its library, it will extract them into the right feature type. So it's coming to the end now, but yeah, this is quite a useful tool for doing some simple, well, not so simple AI, I guess, but for doing some low-cost AI, let's say. So you might want to have a look at that Mapillary. Just go to mapillary.com. Have a look at their capabilities. Goes well with the MX7 because it's all image-based. Okay, so that's kind of, just doing a video log, maybe with just some simple automated extraction. I think the MX7 is worth it for that alone, to be honest. And then other things that people may extract, as we've seen, things like road edges and manholes and other utilities. And for taking measurements, so obviously you can do horizontal and vertical measurements. You can measure offsets, as we've seen. You can also do catenary measurements on suspended cables. You can also measure the areas of polygons and do perpendicular offset measurements. So quite a range of capabilities that you could use with MX7 data. And then, as I mentioned, you can also do asset inspection, and this could be, as I mentioned earlier, it might be doing things like looking at posts and trying to make an assessment, is there room on this pole for my new infrastructure? Or it could be a simple inspection of the road surface and identifying areas of the road that are subject to cracking or potholes. Very simple to do that with the MX7. And then, as we've also seen, we can do more comprehensive data capture, so identifying the feature and lots of other rich information about that feature, including, automatically detecting some measurement parameters like the height of a pole, for example, and things like dates and reference numbers and condition can also, of course, be assessed directly from the images. And then I just wanted to share something a bit different at the end, which is just to give you some indication of the performance of the MX7. So this is a data set that a colleague and myself, we measured some points in the images using RTK. So we were using an R10 at the time, and you'll see we identified these points in the images and measured them using RTK. And then simply what I did was I imported those points into our imagery. So the red dots here are just imported coordinates. So you'll see them meant to sit obviously on things like posts and corners and things like that. And you'll see here that very clearly these points, these RTK points, when they've been imported, come in remarkably well, overlaying on the correct locations on the images. So this certainly, when we first started playing with the MX7, gave me a lot of confidence that the data we were getting was actually probably better than I ever hoped for, to be honest. And that brings us to the conclusion of my presentation for this afternoon. I'm going to hand back to Victoria, who maybe will say something about questions.
Thank you, Pete, for the detailed presentation. For now, we have just one question and probably more are coming. So the first question we have is, does MX7 provide a background map to be used in the field during the data acquisition?
Yes and no is the answer to that question. So we can have a background map when we're capturing, but your system needs to be connected to the internet at the time. So we can connect to like OpenStreetMaps and have that displayed in the TMI software. But you need to be connected to the internet, which maybe isn't as challenging as you think it is, because you could connect your tablet to your cell phone so that you've got an internet connection, and then you can stream the background maps over the internet.
Thank you, Pete. And then the second question is, can we measure cracks from the image?
Yes and no, again, is probably the right answer. So we have no capability currently to automatically detect the cracks, if that was the question. Although this is probably something that we would like to do in the future, let's say. But you can obviously manually see the cracks in the image and very quickly just, draw around them or trace them from the image. The relative measurements, so if you were interested in the length of a crack, for example, the relative measurement along the length of the crack would be pretty good, But what we can't do from image only is, for example, if they wanted to measure the depth of the crack, we couldn't do that from only images.
Thanks. The next one, about the photo attached. How is it exported to the GIS? I think here we are talking about the snapshots which are attached.
Yeah, I can only tell you how it happens, for example, in ArcGIS, but I think other GIS systems would probably be similar. So basically, so when you create a snapshot, you would basically put that in a folder, and you would create an HTML link to that image file. And then in the GIS, you would have the link. So you'd have like an HTML link to that file, and that's how it would recognize it, say, in the GIS system. So you'd just be able to click on it and it would open the right image.
Thank you. Browsing further. Can we measure azimuth?
Can you measure azimuth? Yes, I can't remember if explicitly for example, if you measure a line, if it displays the azimuth, but yeah, you could get azimuth out of it, yeah, sure.
The last one we have for now is in the future question or suggestions from one of our attendees. In a future MX7 webinar, can you show some feature extraction examples per TBC, Trimble Business Center? Maybe
Yes.
we just answer, is it possible or not?
Yeah, it's possible. And we could do that. And in fact, I think Marco did it in one of our previous webinars. So you might want to look back at some of the previous webinars. Marco Bello did one that was using TBC to extract kind of GIS data. It's possible, but it's probably not optimal, to be honest. TBC, it has lots of tools for extracting features, but it's the handling of attributes that TMX is much kind of richer at. It's much better at handling, attributes and data schemas and storing them in a kind of GIS topological fashion. So yeah, you can do some basic stuff in TBC, but it's probably, certainly for me personally, it wouldn't be the way that I would like to do it. I'd much prefer to do it in TMX. CAD is different. If you just want to extract line work, then TBC is fine for that. But as soon as you kind of pass that threshold of wanting to do some quite rich GIS data capture, it's probably easier in TMX.
Thank you, Pete. And more questions are coming. The next one sounds like survey speeds, waterproof, nighttime possibility for MX7. Lots of technical questions around the specs. Put it together.
The nighttime possibility one reminds me of a funny story, actually, that we had one time. Somebody did a demo in Finland, and they came back and said, "There's not, all the images are empty. There's nothing on them." And then later on, I realized it was like winter in Finland, and it was in the afternoon, and of course it was dark. So the images were just black, and we thought originally there was something wrong with the camera. So no, obviously nighttime is probably challenging unless you have very good street lighting. Is probably not recommended, to be honest, although I have heard of people in the past doing surveys of which lampposts are broken and not working. so the bulbs are broken. I've heard of somebody using an MX7 for that in the past. But yeah, probably not recommended at night time. Sorry, what was the other parts of that question?
Waterproof and survey speeds.
Waterproof, I would say showerproof. So Victoria, you might have to help me here. The MX7, I think, is IP54.
Sorry, I don't remember.
Yeah,
by
it's showerproof anyway. So you could use it in light rain, but probably not recommended in pouring rain. Rain is kind of a problem with a camera anyway, because once you get lots of big water droplets on the camera, then your images become more or less useless anyway. So
just to add here that IP is the 65 IP rating, but if you are interested in the more details on technical specs, you always could visit our website geospatialtrimble.com and to check out the latest version of the datasheet for MX7. You will find all of these parameters there.
And then the other question was to do with driving speed, is that correct?
Right, correct.
So speed, yes. The camera, so the limiting factor there is the camera has, I think if I remember rightly, a limit of 9 frames per second. So you can drive perfectly well at like 60 kilometers an hour, no problem with that, but probably 100 kilometers an hour is probably too much. You're probably going to be going a bit too fast at that stage.
Thank you. A couple of minutes more we have, and probably just the last questions. Would it be possible to get a record of the presentation? Yes, that would be. You will all receive the follow-up email with the recordings to the session. And don't forget, we also publish all of the videos out of our webinars on the Trimble Mobile Mapping YouTube channel. Just search for it, sign up, and you will find all of the recordings there. Next one, MX7 maximum operate temperature. So the maximum operate temperature for MX7 is plus 35 degrees. Last question, can you say anything about the price range for the system presented? I think at this webinars, we are not discussing the price range, but you always can consult your local sales representative for more details. Also, the price would depend on the workflow you pick up for your application and tools you're going to use. With that, I want to thank everybody, Pete, and attendees as well. Yeah, see you at our next webinar.
Thank you.
Bye.
Bye-bye.